This is the project for Graph for All by Tiger Graph. The title is Graph for a Better Token Economy. So it addresses the security of the distributed ledger and blockchain stack for cryptocurrency Web 3.0 et al. Of course, the project has to be small, so this and defined, well defined, right? So this project addresses the detection of the fraud rings in money laundering. Money laundering, one of the interesting pattern or challenging pattern in money laundering is the fan in, fan out. Money laundering goes through 3 stages: placement, layering, and integration. Layering is the most complex, where money is placed through a complex web of strategic transactions, right? Mixtures, tumblers, long chain of crypto. And the idea is to obscure the money trail. The 3 examples here, graph 1, you can see this person 1 who is the fraud actor. The money goes through a set of layering. In the end, it comes back to 1, right? So that's why it is red, and that's where it becomes money laundering. Graph 2, what happens is there is one more complexity to it. The 107 person layers it. So you have a layering within layers. Graph 3, 200 is a tumbler. So tumbler is somebody who goes in and distributes. Expands, it's a mixer, this thing, right? So then it becomes more harder to detect. The challenges are, first of all, payment network is different from social and other networks. It is temporal, it is monotonic time, because payment has to be in progressive timing. It's not symmetric. And many concepts like connected components and page rank might not mean much. And more interestingly, the money laundering is not just one cycle. As you can see, there are multiple cycles here. And there is a fraud actor at the head. So the graph algorithm has to figure that out. And thirdly, definitely detecting fraud is literally finding needle in the haystack, class imbalances, long chains, all of these challenges are there. The approach, layered approach, well-defined pipeline, overlay fraud rings progressively. Don't try to do it in one shot. Customize, there are interesting GSQL graph algorithms, customize them and combine them, model them, and all kinds of stuff like that at runtime, and stay in Tiger Graph as much as possible. You'll hear more later. So let us go to the demo. The placement order cycle, I have already run it. That's where you see the graph. Let us run it one more time. It runs and it shows the graph. As you can see, it shows those 3 graphs, and so you can compare this with the graph that I had shown in 4, and it does very well, right? It nicely finds the people at the helm, right? It with a 1, 101, and probably 201. Right? So it does a nice job. Let's go back. So I have all of these details in there for you to look at later. Lessons learned: graph representation is appropriate. Tiger Graph does work well, but spend time thinking and understanding the problem. Think graphs, and more specifically parallel graphs. That takes a little time to think in that way. Draw graph diagrams and do as much as, like I said here, stay true to the platform and stay as much as in the graph domain and the Tiger Graph system platform. And it helps. It comes out very well. Lot of things to try next. Scalability, right? The first is, I do want to load Bitcoin, Ethereum, blockchains. This is like how much? 600 GB of more than that, right? Even for blockchain, it might be 500, 600 GB or more. Cross-ledger tracking will be interesting. Fine-grained temporals, graph neural networks. A lot of interesting ideas to try, and I think that the platform is rich enough to try all of those things. And thank you very much for listening.